my life, I've wondered about existence. What is it all about? Now, having explored many things, but feeling no smarter, I start over. What, I ask myself, can I know for sure? For me, it's the enormity of the cosmos. It stops my breath. Everyone knows that the universe is huge, but no one could have imagined how staggeringly immense the universe or multiple universes may actually be. How vast is the cosmos? I'm Robert Lawrence Kuhn, and this is my journey to find out. I go to England to begin with the UK Astronomer Royal, Martin Rees. Martin's a lord now and master of Trinity College at Cambridge University. He invites me to his elegant on-campus home. Martin, ever since I've been a child, I can't think of anything more exhilarating and majestic than thinking of the size of the universe.
Well, the wonder doesn't diminish even when you've been thinking about it for 25 years in the way that I have. So.
How can we begin to understand, get our arms around, so to speak, the meaning of the universe? How do we begin to understand this?
Well, of course, there are semantic questions about what we mean by the universe, but most of us mean by the universe the largest domain that astronomers can study. And that domain has, of course, been growing with the advance in our understanding and the advance in technology. If you'd asked someone in the 17th century, Newton or someone, they would have realized that our solar system contained the planets orbiting the sun, and there was the firmament of fixed stars, whose distance was rather uncertain at that time. If you'd asked Einstein in 1905 how big the universe was, he would have thought it was the size of what we now call the Milky Way, our galaxy, which extends a distance of maybe 30,000 light years. But we now know, and we've known since the work of Hubble and others in the 1920s, that our Milky Way, our galaxy, is just one of zillions of galaxies which we see with large telescopes. I think most of us would say that it's very likely that the universe, in the form that we see within the domain of our telescopes, extends thousands of times further. But maybe it goes much further still. In fact, you could imagine it going on infinitely. And if that were the case, then we have the fascinating possibility that there may be somewhere a universe exactly resembling ours, a galaxy exactly resembling ours. And so it could be that our domain of space and time, the aftermath of our Big Bang, is vast enough to encompass every possible option. That would be fascinating. But even that is not all. Some people think that our Big Bang is just one of many, and that there could be other Big Bangs which would be in completely disjoint regions of space and time, maybe even embedded in some higher dimension, and they could lead to different cosmoses, just as we can imagine two-dimensional surfaces, each with ants crawling around on them, and one is not aware of the other. So there could be another universe just a millimeter away from ours, but we're not aware of it because that millimeter is measured in some fourth spatial dimension, and we're imprisoned in our three. There are two fundamental questions which are one of the greatest challenges, I think, to 21st century science. The first is, was our Big Bang the only one? We don't know the answer to that. And the second is, if there were many Big Bangs, were they all replicas of each other, or did they end up governed by different laws?
our universe going on infinitely? Multiple universes, different laws, other dimensions? Humanity's vision has expanded so far, so fast. I need perspective. I hear that Max Tegmark, a young cosmologist from Sweden, sees the big picture. He likes pushing boundaries. I meet Max at MIT, my alma mater. Max, when I really want to try to understand reality, all there is, the first question that comes to my mind is, how big is it?
I think that's a fascinating question, and I imagine, the Native Americans who lived here in Massachusetts thousands of years ago, to them, the universe must have been just the part of Earth that they could walk in a lifetime, right? And then gradually, when sailboats were invented and so on, people started discovering that, whoa, the world is just vastly bigger than we thought. And then some clever Greeks figured out the size of this big ball we live on, and the universe, so it became the solar system. and when they figured out how far away Saturn was, they were amazed. Wow, this is so huge. Then there were these little dinky, shiny things, right, the stars, and which were still farther away. And when people realized that they were dramatically farther away than the planets, so far away that it would take light several years to get here, I think that blew people's minds again. And yet, that's still only our backyard, as we've come to realize. And only in 1925 did Edward Hubble realize that this wispy, spiral-shaped nebula called Andromeda was actually what they then called an island universe. Hundreds of billions of stars still farther away. And now, we've pushed the boundary again. And now when people talk about our universe, we usually mean the interior of this sphere here, which is just a part of space from which light has had time to get to us so far.
So what is this?
This is simply the region from which light has had time to reach us here on Earth during the 14 billion years since the Big Bang. And since light can only travel at a finite speed, this is all we can see. And then the million-dollar question is there still more space beyond that or not? And it's funny you ask, because I was at my son Alexander's preschool recently giving a talk about space. And one of his 4-year-old little pals raised his hand and said, I have a question. Does space go on forever? And I was thinking, this is so amazing. This 4-year-old asked a question that I don't know the answer to.
So how do you look at the overview when you sit back and say, how big can it really get? What do you think?
I think it's pretty clear that there is more to reality than what's inside of this sphere. So to me, the interesting question isn't whether there is more, whether there are parallel universes, but how much more there is. How many different levels are there, and what's the nature of all this?
A 4-year-old's question, as profound as any of mine. Shouldn't that tell me something? I'd come to MIT to see Alan Guth, whose startling theory describing how our universe began, it's called inflation, revolutionized cosmology. I'm thrilled to meet Alan, whose breathtaking vision contrasts nicely with his unassuming nature. Alan, you have written down a number that has been the most emotionally effective number that I have ever seen in my life. You have said that the observable universe, what we can see today, the 23rd power, bigger than what we see in our observable universe. That's 100 billion trillion times bigger than what we see. It's astonishing.
Yeah, one of the things that one finds in cosmology that hits one right at the very beginning is that the universe is just plain unbelievably big. Even the observable universe, which you sort of treated as trivial in your remarks, is incredibly big. But as you were quoting me, if a theory called inflation is correct, the observable universe is really only a tiny speck in a much bigger reality. This idea called inflation is a twist on the Big Bang theory, and it proposes that there was a period of exponential expansion in the early part of the universe. And by exponential expansion, what of course we mean is that there was a certain time in which the universe doubled in size, and then if one waits the same amount of time, it doubles again, same amount of time, it doubles again, and so on, this successive redoubling. And that leads to an unbelievably fast expansion.
In inflation, I think you said you have a minimum of 100-fold in a very short period of time, well within the first microsecond of the time of the universe.
That's correct. You need at least about 100 doubling times of inflation to make the theory work. And this number, 10 to the 23, comes from saying we don't really know how much inflation there was. There was at least this much. Let's guess that there was maybe twice that length of time. Why not?
You used the term pocket universe. So what's the pocket?
I'm using the word pocket to mean a piece of space that inflated together.
Yes, right. The implication is that if there's this pocket universe, there may be other pocket universes, and infinite is a possibility.
That's right. I think the bottom line here is that in essentially all theoretical models of this phenomenon called inflation, once inflation starts, it never really completely stops. What happens is it stops in places and produces these pocket universes, but in other places it's always still going on, producing more and more pocket universes. There'd be an infinite number of these pocket universes.
I'm dizzy. All the vast expanse of our visible universe is but an insignificant speck in Allen's inflating universe, which itself is only one pocket universe among an innumerable number of them. If, indeed, the cosmos is unimaginably immense, the person who gives us eyes to see it is Andrei Linde, originally from Russia, now at Stanford. I hear that Andrei's universe grows chaotically and eternally. We meet at SLAC, Stanford's linear accelerator. How can we begin to understand what you and your colleagues have done with the incredible size of what this universe may really be?
Well, our universe is approximately 14 billion years old. So during this time, light was traveling 14 billion years multiplied by the speed of light. So this is what we can see right now in the telescope. We can see, well, the maximal distance possible, kind of. But what we then try to explain, why this huge part of the universe which we see right now, why is it so uniform? And in the process of trying to understand it, we invented a theory which is called inflationary cosmology. And this theory tells you that actually you ain't seeing nothing yet, okay? Well, the first numbers which came to our mind when we were studying inflationary theory, we got the numbers like 10 to the degree 1,000 centimeters.
That means a 1 with 1,000 zeros. Oh.
And then when we start studying it more, we got different number. It is 10 to the degree approximately 1,000 billion zeros. And then when we, well, came to terms with these numbers, because it was kind of painful. But irony was that at the moment when we started studying it further and further, we understood that these 10 to the 1 billion or something like that, this is just a fraction of the universe. And in fact, the universe consists of enormous balloons, enormously large parts, each of them like 10 to the million, so 10 with a million zeros. But then there are many of them, and if you ask me how many, I would answer you infinitely many such balloons. This is what we didn't expect.
I mean, it's so absolutely overwhelming to conceptualize it. Now, here we have different bubbles, and each one of those are a universe like ours. So where are we?
Well, we may be living in this red bubble, And this red bubble has a size like 10 with a million zeros, so it's an enormously large one. And we can see only a tiny, tiny part of the surface of this enormous balloon of a size only 10 to the 28 centimeters. And it's kind of a joke, because 10 to the 28 centimeters is everything that we can see right now using most powerful telescope. This is enormously large distance, but it's just a tiny fraction of the whole universe of this type. And this is just a part of the universe, because there are many other balloons here, and each of these balloons is enormously large. So we have a collection of all of these balloons, and this collection, the total of it, is just infinitely large.
Enormity beyond comprehension. I cannot say more. I am overwhelmed. I learn of a conference of cosmologists in Iceland, organized by FQ of X, a new organization dedicated to foundational questions. Max Tegmark, my new friend, is the director, and he invites me along. Max is running the conference. I catch him in Iceland's famous hot springs, the Blue Lagoon. Am I ready for new kinds of universes? So Max, tell me the truth. In this environment, I mean, this is a truth-seeking environment. You're no clothes, heat from the earth. I mean, do you really believe in parallel universes?
I really do. I really do believe in parallel universes. And believe me, it's hard to believe it sometimes because it's very counterintuitive, right? And sometimes I even find my emotions to be out of sync with what I really believe. Like, I remember I used to think, I hope I'm going to get tenure. And then I realized that doesn't jive with what I believe, because of course I'm going to get tenure and I'm not going to get tenure in various parallel universes. So maybe what I really mean is, I hope I'm going to be in the parallel universe where I get tenure. But that's nonsense too, because I'm going to be in both of them, right? And then I hope maybe I'll get tenure in most parallel universes. But that's also nonsense, because
there's an infinite number of everything.
Well, you can actually calculate deterministically what fraction of them I would have gotten tenure in. Fortunately, I got tenure in this particular parallel universe, and I've stopped thinking about that question. But it really is difficult to sync one's emotions with what one actually believes. And it ultimately just comes down to the fact that we evolved to have intuition for things which were useful for our ancestors, right? And if one of my ancestors spent too much time thinking about quantum physics,
he would have been eaten by a lion.
They wouldn't have noticed the lion when it snuck up from behind and cleaned right out of the gene pool.
Different universes, multiple universes, parallel universes, they all can drive you nuts. Our cosmologists should take a break. How to take a break in Iceland? Glaciers, snowmobiles. What have I gotten myself into? Feigning fearlessness, I ride with Alan Guth. It's a first for us city-bred boys. He's driving, I'm hanging on, nervously. I have more confidence in Alan's equations than in his snowmobiling. And so I think, it's no big deal that Alan's cosmic inflation occurs in a trillionth of a second, because every second riding with Alan feels like eternity. Two days later, at Iceland's hot springs, I see Alan again. When you think about cosmology, from the standpoint of humanity, what are the implications?
One of the things one, of course, learns from cosmology is how very small our whole civilization is. We live on a planet that's part of a galaxy with about 100 billion stars in the galaxy. The galaxy is about 1 in 100 billion galaxies in the visible part of the universe. What that means, I think, is certainly not that we're unimportant, but that it means we have to make our own importance. That man is important because we're important to ourselves and because we give life a meaning. And I think part of that meaning is our quest for knowledge about the universe that we live in. It's really amazing, I think, how far we've come in being able to understand the things that we see around us in the universe.
You know, I think this is such a critical point because on the one hand, we see ourselves an even smaller part of the vastness of reality. With inflation and the multiple pocket universes, maybe an infinite number. But on the other hand, we understand it. To me, that's incredible.
Yeah, no, I agree. It is incredible, although we should also be completely honest about this. There are some things we understand fantastically, surprisingly, I should say, well. But at the same time, our model of the universe is in many ways more confused than ever. About 70% of the universe we think is this stuff called dark energy, and we don't really know what that is. Another 25% is what we call dark matter. We don't know what that is either.
But we know that there is such a thing, or there's something to be explained there,
yes,
which is so far beyond our common intuition.
Yeah.
To me, that by itself is remarkable.
Yeah, no, I agree. I think it's remarkable on both sides. It's remarkable how much we understand. It's also remarkable how much there is that we don't understand.
The more we learn about the cosmos, the larger it becomes, and the smaller we seem. I have so many questions, but I keep returning to cosmic vastness. I must see Paul Davies, a daring cosmologist not bound by anyone's tradition. What does Paul make of multiple universes?
Well, that's what we were told. I usually say 2 cheers for the multiverse, because there are good reasons of physics and cosmology for supposing that what we see may not be all you get, that there may be other regions of space and time that could be different. So it's not an unreasonable speculation. However, it falls far short of being a complete theory of existence, which is often presented as if there's a multiverse, we can forget about all the mysteries of the universe because it's all explained. Everything's out there somewhere, end of story. Well, it's simply not true, because to get a multiverse, you need a universe-generating mechanism. Something has got to make all those big bangs go bang. So you're going to need some laws of physics to do that. And you can say, well, where have they all come from? So all you've done is shift the problem of existence up from the level of universe to the level of multiverse, but you haven't explained it. I suppose for me, the main problem is that what we're trying to do is explain why the universe is as it is by appealing to something outside of it. In this case, an infinite number of universes outside of it. That, to me, is no better than traditional religion that appeals to an unseen, unexplained God that is outside of the universe. I'm prepared to accept that what we see isn't the totality, that there may be regions of space and time, other universes, if you like, that could be rather different from what we observe. But I certainly don't believe that all possible universes are out there, and that the explanation for the universe that we see is because everything imaginable exists, and that this particular one we see just because it happens to be one that we live in. I think that falls far short of a proper explanation. Indeed, I think it's contradictory and absurd.
How vast is the cosmos? Whenever we've set its limits, it was always too small. The cosmos didn't change, of course, but our feeble vision of it surely did. Anyone contemplating the big questions of existence must confront the staggering size of our universe and the real possibility of multiple universes without number or limit. This is not science fiction. This is our cosmic home. simply appreciating the ineffable enormity of the cosmos is already closer to truth.
For complete interviews and for further information, please visit closertotruth.com.